In this video, we're going to explore hypothesis testing for proportions. Now, just like the mean, when we're testing the mean of large samples, we use the z-test when we're testing population proportions. To find our critical values, we're going to do the exact same thing. We need to know our alpha value, and then we're going to use the appropriate formula whether we have a left tail, right tail, or two-tailed test. Now, for example, if I had a left-tailed test with an alpha of 0.03, I plug that into the formula and find that the z critical value be negative 1.88. I plot that on my bell curve and shade to the left. So anything in the red would be part of the rejection region. If I did a two-tailed test at 0.03, then I would have to take the value of the norm.imv and do 0.03 divided by 2. That'll give me the negative, or the lower bound tail critical value, and then the positive will be the upper bound critical value. And then I shade my tails. Now, if I want to use the z-test to test my proportion hypothesis, the first thing I have to do is check to verify these two inequalities are true. I take my sample size and I'll multiply it by the success proportion, make sure that's greater than 5, and I'm going to take my sample size, multiply it by the failure proportion, and make sure that's greater than 5. If those two are true, then I can use the z-test for my hypothesis. Other than that, I'm going to follow the standard t-test. I'm going to state my claim, my null, my alternative hypotheses. I'm going to create my critical values and rejection regions. I'm going to find my z-score using this formula where the p-hat represents my sample proportion of success. The p is the population proportion of success that I'm testing against. And this p and q are based on the population that I'm testing against, the p and the q there, and my sample size. Then I just determine whether I fall in the rejection region and then interpret. So let's say I have this problem where Coke claims that fewer than 30% of people prefer Pepsi over Coke, and you want to test it with a sample of 500 people, and you find that 130 people prefer Pepsi, and you want to know, is that enough to support their claim? First, I need to make sure a z-test is possible. So I do 500 times 30%, that's 150, so that's good. And then I do 500 times 70%, that's 350, that's good. Now I'm going to look at my claim, which was that less than 30% people prefer Pepsi. So that helps me set up my null, my alternative hypothesis. Since it's a less than in the alternative, I'm going to use a left-tailed test. So that tells me which formula to use to get my critical value, which is negative 1.645. I'm going to shade that. Now I can go through and find my z-score related to the sample data. But first I want to know what my p-hat is. So it told me that it was 130 people preferred it out of 500, and that's about 26%. Now I can plug everything in the formula. Here's my sample proportion, the testing proportion that was claimed, and then I used the claimed versions to help me here with the denominator, and there's 500 in my sample. That gives me negative 1.952. And if I look, that would fall within my rejection region. So I'm going to reject the null hypothesis. Thus, at the 5% level of significance, there is sufficient evidence to support Coke's claim that fewer than 30% of people prefer Pepsi over Coke. Let's look at another example here. Let's say Apple claims that on average 75% of teens prefer the iPhone over Android phones. And you want to test the claim by randomly sampling 80 teens. And you find that 65 prefer the iPhone. And you'll know, is this enough evidence to support the claim? First, I want to make sure that I can use the z-test. And I use 75% and 25% since those are based on the claim. And both of those work, so yes, I can use the z-test. So the claim was 75% of teens prefer iPhone. So my null hypothesis is where the claim is. And then the alternative would be that it's not equal. Since it's not equal, I'm going to be looking at a two-tailed test. So I'm going to find my lower critical value. And then the upper critical value is the positive version of that. So I've got negative 2.576 and positive 2.576. Next, I need to know my sample proportion. In this case, it was 65 out of 80 preferred it, so that's 0.8125. And I can use that to find my z-score. So 0.8125 minus what they're claiming, which is the 0.75. And then I'm going to use the 0.75 and the 0.25 in my denominator and my sample size of 80. When I do that, I get 1.291. If I plot that, that falls in the failing to reject region, so I'm not going to reject the null hypothesis. So at the 1% level of significance, there is not sufficient evidence to reject Apple's claim that 75% of teens prefer the iPhone over the Androids.